We're given a hollow tube with an outer diameter of 6 inches and an inner diameter of 4 inches. We're asked to determine the moment of inertia and the radius of gyration with respect to the polar centroidal axis. Let's start by finding the polar moment of inertia, J, and the radius of gyration, K. First, let's calculate the outer radius, capital R, which is half of the outer diameter, or 3 inches. Similarly, the inner radius, little r, is half of the inner diameter, which is 2 inches. Here's a visual representation of the hollow tube's cross-section. The moment of inertia about the x-axis and y-axis for a hollow tube is given by the formula pi over 4 times capital R to the 4th minus little r to the 4th. Substituting the values, we get 3 to the 4th minus 2 to the 4th, which simplifies to 81 minus 16, and further to 16.25 pi inches to the 4th. The polar moment of inertia, J, is the sum of I sub x and I sub y. Since I sub x and I sub y are equal, J is simply 2 times I sub x. This gives us 32.5 pi inches to the 4th, or approximately 102.1 inches to the 4th. Now, let's find the cross-sectional area, A, of the hollow tube. This is given by pi times capital R squared minus little r squared. Plugging in our values, we have pi times 3 squared minus 2 squared, which simplifies to 5 pi square inches, or about 15.71 square inches. Finally, we can calculate the radius of gyration, K, which is the square root of the polar moment of inertia, J, divided by the area, A. Substituting the values we found, we get the square root of 32.5 pi over 5 pi. This simplifies to the square root of 6.5, which is approximately 2.55 inches. So, the polar moment of inertia is approximately 102.1 inches to the 4th, and the radius of gyration is approximately 2.55 inches.